Okay, so let's do question number 30. So what you need to do is to actually read this problem. So, and then understanding what's going on here, right? So it looks like that initially the solution that's contained this guy and that guy is at the equilibrium. And you already know that the reaction is given as is, like this. So at the equilibrium, everything is sort of like static, right? Some of those guys trying to become product, and then product trying to go back to the reactant, and then that because the number going left to right or the right to left is pretty much the same, so you don't see the changes. So that's what the equilibrium really means. So at the equilibrium, nothing is happening, so it's not really interesting. But when you actually add extra 0.3 mole of this guy into the solution, then you have extra 2HI, right? And that extra stuff wants to go back to the reactant. So that will produce a reactant, right? So let's just try to write out what's going on the paper so that you will understand these things a little bit better. So it's all about the reading comprehension here. So initially you have 1 liter solution containing HI of the 0.49 molar, and then H2 of 0.08 molar, and I2 of 0.06 molar, and then you are going to add extra 0.3 mole of HI to this solution right here. Now, what's the new concentration of HI here? New concentration of HI is because this one right here has a volume of 1 liters, 1 liter solution containing 0.49 mole of HI, right? That's what the capital M really means, right? Number of mole per liter, and volume is liter, so this really means that you have 0.49 mole of HI in 1 liter, right? So you're adding 0.3 mole of HI, extra stuff, then the new concentration, so the number of mole in this solution is going to be 0.79 moles of HI, which means that the new concentration is going to be 0.79 molar, right? And once you add the extra stuff, then you're going to form more reactant, right? Because you have extra product. So when you actually try to write out the reactions, you should always write out the equilibrium constant, and then you might actually want to let's draw it up. You might actually want to write out the concentrations for the at the equilibrium. I don't know if you can actually see this one or not, but that's the 0.49 to the power of square divided by 0.08 to the, not the power of 2, sorry, that's wrong, 0.08 times 0.06. I just plug the values here into here, right? So you can actually calculate K, and that's pretty much all the information given by the program. What you really want is what is the concentration of HI if you wait long enough? What is the concentration of H2 once you wait long enough, or I2, right? What is the concentration of H2, I2, HI after the new equilibrium? So let's calculate that one. So I already Let me just write just erase everything. So I have actually constructed the rice table. The rice table is R stands for the reaction, I stands for the initial conditions, C stands for change, and E stands for the equilibrium concentrations. It's the final concentrations. Right? So let's just fill in the blank here. The reaction is H2 and I2 becoming 2HI. And the initial concentration here, oops, I should probably go, that's dangerous. I did this once and then this is the second take, so let me just go back to what I was saying. So whenever you're dealing with this type of problems, what is the final concentrations of the reactions, those type of questions, right? Then you should always write out the rice table. R stands for reaction, I stands for initial conditions, C stands for change, E stands for the equilibrium concentrations. This is the final concentrations. And for the reaction, you literally write the chemical reactions. So H2 plus I2 trying to become 2HI. And then the initial concentrations for this one, the H2 is 0.08, and then the I2 is 0.06, and then the HI concentration is 0.79 for the reason that I was actually describing before, that it used to be 0.49, but now that it is 0.79 because you added 0.3 more to the 1 liter solutions, right? Now, what is the change here? The change here is going to be equal to twice as much as whatever the value that we are going to produce. So let me just start out with think about the change of H2 here. I think that probably make better sense doing it from that way. So I just created this number right here. That's like could be any numbers. I just pick 0.1. So if I actually think about what is the change of the H2, because you are adding the extra HI, that extra HI wants to go back to the reactant. So this is going to be, this reaction is going to form more H2, right? So I am going to put whatever the value that is to be X, value of X here. And same goes here, right? You're forming extra reactant, right? Because you have excess product, right? Excess product is going to produce excess reactant. More excess product will form more reactant, right? So this should equal to the same amount, right? 0.1, whatever this number is. And then what happened to this HI here? Because you started out with an excess amount of HI that will go back to the reactant. This is going to decrease, right? But decrease twice as much as this guy, right? So multiply by 2, right? Because if this number decreases by factor of 2, then you're going to form half of that and half of that, right? Then what is the final concentration? This number is going to increase to that number, and then same goes here. This number is going to increase by that much, right? But for this one, you start out with this number, but it's going to decrease by that much. Alright. Up to this point, I hope everything makes sense. this number, once again, this could be any numbers. It really doesn't matter. Just pick numbers. Just pick some number. Okay, so I'm just going to put these things to be 0.1 for now. It looks a little bit cleaner that way. Now, I also want to know what the k value of k was, and the value of q right now. So the value of q, remember that this is product over reactant, right? But product is having a coefficient of 2, so this to the power of 2 divided by parenthesis open, this multiplied by the iodine concentrations at the equilibrium constant, equilibrium, right? So that's the Q at current values right now. Now, what is the value of K? What's the value of K supposed to be? The equilibrium, it was at the equilibrium when this guy was 0.49, right? So 0.49 to the power of 2 divided by parenthesis open, that multiplied by this, right? This was from the problem. So K is about 50, right? And then the current value of Q, when you add it extra 0.3 more of the HI, you have a Q value of this much, right? And if you wait long enough, this Q is going to approach 50, right? So let me just try to write out these things right here, and it will approach to this value right here. So the key here is that number right here. So at this point, we don't really know what this x really is, but eventually by changing this number 0.5, it will approach to this value right here. So how do you get that? So this one right here, you're gonna actually modify your Excel worksheet. So go to File tab, the left top corner, File, go to Option. You do this only once, and once you do this, then you don't have to do it anymore. Excel add-in, choose add-in right here, and then here the Excel add-in, just click Go right here, and then just take a look at this solver add-in. Make sure that thing is checked, and you might want to keep these things to be checked for the later use. So I usually check that one, and I check that one. That's good enough. You really need this one only, but doesn't matter. It's gonna come in handy later on. Not for this class, but for the quantitative chemical analysis. But this one is good for this class. So you're gonna add this. You do this OK. I already have this one, so I don't want to touch that one. But you need to actually press OK. Okay. So once you OK that one, then go to the Data tab, which is Home, Insert, Draw, Layout, Formula, and then Data. Click Data. Now you actually should have Data Analysis and Solver. So click on Solver right here. If I click on Solver here, you get this beautiful things. And the set objective is the one. I want this value, so I'm going to click this particular Q values, current value of Q, to have a value of, I wonder if I can actually do this. Oh, I cannot do this. Okay, the value of 50, because this thing is 50.02. By changing changing the value of x, by changing the value of x right here. Did you follow what I did? So right here, I want this value to change to 50.02, which is the value of k right here, by changing that guy right here. So in other words, I'm modifying the value of x. I'm telling computer to look for this number that will make this q to be equal to this guy. And then when you do that, just click solve at the end, and then solver found the solution. That's what it says. And that's right there is the actual value of x here. So now you already have the final concentrations already. That value right here is the final concentration of HI. That concentration is the final value of the I2, and that is the final concentration of H2. It's simple, right? So, and once you do this, then you really just repeat the same stuff over and over and over again. It's sometimes you have more than 2 reactions or 3 reactions, so you may need to actually change the Q, K and Q, but basically it's going to be the same procedures over and over again. And look what I have here. Q is extremely close to these values, right? So that's good. So we actually solve the problem instant.